So this week we're going to take a look at compound interest problems. These come up a lot when we look at putting money into like bank accounts or CDs, things that gain what's called interest. The idea behind interest is that if you put money into an account, over time the bank will give you more money even if you don't put anything else in. And that would be exponential growth. So if you say put in $1,000 into an account, as time goes on, your account will go up and up and up like that. Now, the formula for calculating compound interest can look daunting. We'll break this down and talk about what each one of these letters represent. And basically, all you need to do is to plug in information that's going to be given to you into the correct spots, and you should be good. So first we have this A. That would be your final amount. So your final amount, what is going to be in your account, when it's all said and done at the end of this problem. This P stands for principal amount, which another way of thinking of that is your start amount, your initial amount. Okay, so what you initially put into your account. In the example that we just went over, that would be 1,000. So if you put 1,000 into your account day one, 1,000 would go right in for P. R would be your rate, your interest rate the bank is giving to you. Now all this information again should be given to you in any of the problems that you're given. The big thing with rate is you have to remember to take it from a percent, put it into a decimal. And that's something that we'll go over again. As you can see, there are two n's, and it's the same thing. So whatever you put in for n in this denominator, you'd also put it in your exponent. And what n stands for is the number of times interest is applied per period. So some accounts might accrue interest quarterly, some might do it daily. So depending on what is given to you in the problem, you'll have to put in a certain number in for n, which we'll go over in the next slide. And finally, T would be time, how long you're going to keep your money in this particular account. So as far as the number of times compounded, or the number of times your interest is applied, what our n equals, in the problem, they might give you any of these words. So if it says that you accrue interest daily, that means you're going to get interest every single day, which is 365 days a year. For all these problems, if they say daily, we'll assume that it's not a leap year, so we'll just keep it as 365. For weekly, your n would be 52, since there are 52 weeks in a year. Bi-weekly would be 26. So if they put in interest, or your interest amount every other week, it would be 26. Monthly would be 12. Semi-annually, meaning you'll get interest twice a year, and then annually would be once a year. So depending on what is told to you in the problem, these are most likely going to be the numbers you're going to put in for n. When it comes to figuring out the number of times you gain interest, or number of times that your account is compounded each paying cycle, you have to look into the problem and look for some of these keywords. Now these keywords will tell you what you should plug in for n. So if you see that you're gaining interest daily, you're going to plug in 365 for n. With all these problems, we're going to ignore leap year, so we're just going to use daily as 365. If we gain interest weekly, it would be 52, and it would be 52 since there are 52 weeks in a year. If we accrue interest bi-weekly, that means we're going to get interest every other week, which means n would be 26. If in our problem it says we are gaining interest monthly, we're going to plug in 12 for n. If we see it's going to be quarterly, if you think about breaking a year up into quarters, that means we're breaking up into fours. So if we see we gain interest quarterly, we're going to plug in 4 for n. Semi-annually, meaning we're going to gain interest twice a year, once at the halfway mark and then once at the end. Then annually would be once a year. So if we look at number 1 in your worksheet, we have a newborn child receiving a $20,000 gift towards a college education from her grandparents. How much will the $20,000 be worth in 17 years if it's invested at 7% and compounded quarterly? So I included the formula there for us, and we're given everything we need in the problem. We just need to make sure we take all the correct numbers and plug them into the right spots. So first, if I look at this $20,000, that is what we're initially given. And if you think back to our last slide, our initial or our principal amount is going to go in for that p. So if we start to build our equation, we're going to plug in 20,000 for p. We always have 1 plus. Now if we look back into our problem, we're given a rate of 7%. The big mistake a lot of people will do is they'll put 7 right here, which is not what we want to do. We can't plug in a percent into an algebraic equation. We have to make that a decimal first. So if you remember to change a decimal, or a percent rather, into a decimal, what you're going to do is you're just going to divide it by 100, or you move the decimal point over 2 times. So if the decimal point was here, it gets moved over 2 times. So as a decimal, it's 0.07. Again, you can think of it as 7 divided by 100. That's also 0.07. So we're going to plug in 0.07 here. Now n, remember there are 2 places. And if we look back into our problem, the buzzword that was given to us was quarterly, meaning we're going to gain interest 4 times a year. So I'm going to plug in 4 for n here, 4 for n in my exponent. And then finally, the time that was given to us will be 17 years. So I'm going to plug 17 in here. Now, one thing I do want to point out is that this 4 times 17 is both in the exponent. Now, I'm going to show you guys how we can plug that into our calculator in another video. But this is what we need to plug in for, and we are looking for A, our final amount, how much we're going to have in 17 years. But when you plug this in, your final amount will be about $68.44. Now if we jump ahead to number 3, similar problem but with a little bit different of a twist. So in number 3, if an investment company pays 6% compounded semi-annually, how much should you deposit now to have $10,000 5 years from now? So if we think about our formula, and what we need to plug in, so easy one is we know our rate is 6%. So if we're thinking what we need to plug in, our rate is 6%, so that's going to end up being 0.06. Remember, we need to change that to a decimal. And it's compounded semi-annually, so that's going to be what our n is. Semi-annually, if we think back to our last slide, would be twice a year. We're going to look at it over a 5-year period, so time is 5. Now this is where we want to be careful. They told us that it's going to be 10,000 at the end of this cycle. So we were actually given the final amount. So that's going to go in for A. We weren't given the principal. That's what we're trying to find. So we're going to plug this entire part into our calculator. If you don't have a calculator, you can use Desmos. Again, I've uploaded another video showing you how to plug that into a calculator. So if you take a look at our YouTube link, you'll see that what we have in parentheses ends up being 1.34. Now to get P, your starting value by itself, we're just going to divide by 1.34. And P ends up equaling $7,462.69. All right. So that would be our initial amount, what we would need to deposit in order for us to get 10,000 5 years from now.